All right, so today our learning target is up here. I can find trig values for specific angles around the unit circle. Okay? And you just did a couple. All right, you just did sine of 45, cosine 45, tangent 45, and you also did the secant of 60. So you did a few of them, but I want you to be able to find trig values for any angle around a unit circle or just a circle in general. Okay? So a quick refresher. If this was a unit circle, how long is the radius? 1. And the equation for the unit circle would be what? X squared plus y squared equals 1. Okay? Now, if it's not a unit circle, if it's a circle with a different radius, any number, okay, then what is the equation of this circle? Doesn't change much. Look at your triangle. What would the equation of the circle be? What would the equation for every x and y value on the circle, how could that be represented? Look at your triangle. On a unit circle, this number was what?
1.
And what was the equation? So when the radius is not 1, then you could, if the radius would be any number r, then what's the equation for that circle?
X squared plus y squared equals
X squared plus y squared equals r squared, where r is any radius, right? Okay, does that make sense? Pythagorean's theorem?
Yeah.
Okay? Alright. Now, no matter where I draw a triangle here, okay, even if I would draw it in the first quadrant, let's say this is some x, this is some y, here's my reference angle, this would be x, this would be y, that would be r, right? Okay? And I could draw an angle in any quadrant I wanted to. The relationship would still read x squared plus y squared equals r squared for any coordinate around the circle. Alright? So a little quick review then, to kind of put it in terms of x, y, and r, to think about it. The sine of theta is always equal to what value over what value? Y over r, right?
Yeah.
Okay? And if it's a unit circle, then r is 1, so really then your sine value is just whatever y is. Okay? Cosine is
X over Y.
x over r. Tangent is
Y over X.
y over x. And if you know those three, you can figure out the last three, right?
Yeah.
Okay? So the biggest thing, again, we talked about the other day, remember, sine is your y value, cosine is your x value, tangent is your y value divided by your x value. Okay? So keep those things in mind as we start to do problems like this. Okay? Now, so sine of 60 degrees. Okay? If you aren't getting that in the habit of kind of recognizing what that answer is going to be, if you can't visualize the 30, 60, 90 triangle, again, I would kind of draw the picture a little bit here for starters. Okay? Again, I don't think you need to draw the picture every single time, but maybe at the beginning you will. So the sine of 60. Draw that little 60-degree angle, make a right triangle, label the sides, and then do sine, right? Opposite over hypotenuse. X root 3 over 2x would reduce to what? X root 3 over 2x would reduce root 3 over 2, right? Okay? So now the sine of 240. Okay, well where's 240? Quadrant 3, very good. Somebody, I think Chris, you said it. Okay, quadrant 3. What's my reference angle? 180 to here. Remember this was 240. So 60, right? Okay. Here's my short leg. It'd be negative x. The hypotenuse is always positive. We talked about that yesterday. and this would be negative x root 3, right?
Yep.
So what's the sine of negative 240? Well, you just use that reference angle and you do opposite over hypotenuse. Negative x root 3 over 2x would reduce to negative root 3 over 2, right? Same value, one was positive, one was negative. Why? It's a different quadrant, right? Okay? In quadrant 1, when you do y over r, in quadrant 1, when you do y, isn't the y value positive up here?
Yeah.
So won't sine of any angle up in this quadrant always be a positive? Won't sine of any angle down here in the third quadrant always be negative? Because why?
It's a different quadrant.
It's a different quadrant, and what specifically is negative down here? The y value, right? Because anytime you're doing sine, you're always doing opposite, which represents our y value. And isn't the y value always negative down here?
Yeah.
So sine will be negative down here. What will sine be in this quadrant?
Negative. Positive.
Okay? So sine is positive, positive, and then sine is negative, negative. Right?
Yep.
Okay? But the values are going to be almost the same. I'm going to give you either 30-degree angles, 45-degree angles, or 60-degree angles. They're just going to be in either the first, second, third, or fourth quadrant. Okay? So any 60-degree angle, 60-degree reference angle, your answer will always be root 3 over 2, except sometimes it'll be positive, sometimes it'll be negative. Okay? So you should be able to know two other sine values right now pretty quick, without having to do any work, because we've done the work. The sine of 120. Well, 120 is in what quadrant? Second. What's still the reference angle for a 120-degree angle? 60. So I'm working with a 60-degree angle again. This is like saying this exact problem. Sine of 120, you actually just need to think, what's the sine of 60? So the answer again is root 3 over 2, and is it also still positive?
Yes.
Because it's in quadrant 2, where y is always positive.
Right.
Okay, so this would still be root 3 over 2. Okay? Let's hit the last reference angle of 60 in the fourth quadrant. That'd be the sine of how many degrees? 300. When I ask you for the sine of 300 degrees, I'm still asking you for the sine of a 60-degree angle, except it's in the fourth quadrant.
So it's negative.
It's negative root 3 over 2. Okay? So you can really start to rattle off a lot of answers here once you understand that they all have the same reference angles, and therefore they're going to have the same x and y and r values as anything in the first quadrant. You just need to watch your positives and negatives. Okay? These are all angles that have a 60-degree reference angle. So I know what the reference angle is because I know it has to be 60 degrees away from the x-axis. This is 180, right? What's 60 degrees less than 180? 120. What's 60 degrees more than 180? 240, right? So I know the values that are going to have 60-degree reference angles. And you're always going to get values that either have 60 or 30 or 45-degree reference angles. Yes, sir?
What are the side lengths for the 30, 60, 90 triangle?
Across from the 30 is x. Across from the 60 is x root 3. And the hypotenuse is 2x.
Thank you.
Yep. Okay? See these letters up here? Okay? All students take calculus. You can make up your own if you'd like. There's plenty of other ones out there. Okay? This is my nerdy math one, okay? Here's what it stands for. A is for all of them. What that means is all trig values are positive here in the first quadrant. All of them. Sine is positive, cosine is positive, tangent is positive. The reason why? Y is positive, x is positive, right? In the first quadrant? Yeah. Second quadrant. You guys talked about how sine is positive here, right? Will cosine be positive? No, because cosine deals with your what value? X value. And in the second quadrant, what is my x value up here?
Negative.
X value is negative, right? So cosine will be negative over here. Tangent is y over x. Well, y is positive, x is negative. When you take a positive divided by a negative, what do you get? A negative. So tangent will also be negative up here. Okay? So sine S The sine values are the only ones of the three main ones, sine, cosine, tangent. I'm not talking reciprocals right now, okay? I'm just talking the three main ones, sine, cosine, tangent. Sine is your only one that's positive here in the second quadrant. Third quadrant, take. Tangent. Why is tangent positive down here? Yeah, negative divided by negative makes positive. Okay? Fourth quadrant.
Cosine.
Cosine's the only one that's positive because cosine has to deal with your x values, right? Okay? Alright? Kind of getting that so far? Alright. So what you're going to have to be able to do is you're going to have to be able to rattle off a lot of these trig values, okay, without much difficulty. So I could ask you for the cosine of 150 degrees, and I want you to be able to get that fairly quickly. Okay? Some of you are going to draw pictures for a while, and that's perfectly fine, okay, but we're going to get you past drawing pictures, because you're going to do enough of them, okay? Cosine of 150, what quadrant? Second quadrant. What's the reference angle? 60. Careful. 30, because we always need to think how far is it away from the x-axis, right? 150 degrees gets me 30 degrees away from the x-axis. So really, I'm just looking at a picture that would look something like this, right?
Yep.
You guys with me? That's 150 degrees right here. Anybody? Questions so far? Label your sides. X, 2x, x root 3. That's negative, that's positive. If I were going to do cosine of 150, cosine is adjacent over hypotenuse, negative x root 3 over 2x. Shockingly, what do we get? Negative root 3 over 2. It's amazing how these values are the same over and over again, okay? But it's all because they come back to these same two triangles that we're dealing with all the time. Okay? What's the sine of 150? I already got the picture here for you. What's the sine of 150? Probably keeping you guys a little while here today, so. We got 2 lines, right?
You have one.
We have ILT.
Oh, we do?
I'm probably keeping you a little bit because we took a lot longer than I wanted to on that initial
I was
trial.
really confused.
That's so good. The ILTs written in are kind of confusing.
They're not colored right,
Yeah.
right? Yeah.
1/2.
1/2. Yep. 1/2. Okay. Sine of 150 is 1/2. Opposite over hypotenuse. Okay. So, kind of, sort of. Feel like you could at least draw pictures if you needed to for a while.
Yeah.
Yeah.
Okay. Now, here's where I want you to get. All right. Here's where I want you to get. Let's say I ask you for tangent of 240. So you think 240, third quadrant. What's my reference angle? 60. Okay. Then I think about that picture. Okay. I think about this picture. Think about this picture. What's the tangent of any 60? X root 3 over x, which is really just root 3. Okay? So really, all I'm asking you for is what's the tangent of 60? You'll get to know, oh, that's root 3. And then you think, okay, it's in the third quadrant, so is it going to be a positive root 3 or a negative root 3 down there?
It'd be a negative.
Careful.
Oh,
Positive, because in the third quadrant, tangents are positive, so this will be positive root 3. Okay? So a lot of people, when they do these, like to just have the two pictures of the triangles kind of handy or nearby to refer to. Alright, so that way when you do them, you can just kind of quick glance at them and figure it out without having to draw the axes, draw the triangle exactly in the right spot every single time. It'll go a lot faster for you. But at start, some of you are going to do this for every problem, for every angle. That's okay. But you'll eventually see you don't need to do that. Okay? Alright? There will come times where you don't get a 30, 45, or 60 degree angle. You'll get 0, 90, 180, 270, 360. You'll get an angle that's right on an axis. Okay? Here's how you do it. Let's go sine of 90. Okay. Think back to your unit circle. think back to your unit circle. Recall that these coordinates were on that. This is, I think, the easiest way to do them. Okay. Remember, on a unit circle, x is your what value? Cosine or sine?
Sine.
X, remember, is this way, so it's always the adjacent part, making it x your cosine, and y is your sine. Okay, x is cosine, y is sine. So when I ask you for the sine of 90 degrees, here's how I like to think. Go to 90 degrees, that's right here, right? Sine is the y value right here. What's the y value right here? 1. That answers 1. Okay. Here's the other way to think about it. Remember, sine is y over r, right? If you think about this 90-degree angle right here, okay, the y value is how much?
0.
So the y value is 1. The r value also is 1, right? The radius is 1. Yeah, because it's a unit circle. And what's 1 divided by 1? Still 1. Okay, that's another way to think of it. I really just like the coordinates myself. I just remember that cosine is my x, sine is my y, and tangent is my y over my x. Okay, I just kind of remember those things. So what's the cosine of 180 degrees? $180 is right over here, right? Cosine is your x value. There's my answer, -1. Okay? How about the tangent of 180 degrees? 180, y divided by x. 0 divided by -1 is 0. Here's one, there's a couple that are going to mess you up. Tangent of 90, y divided by x. 1 divided by 0, undefined. Can't divide by 0, right? 1 divided by 0 is impossible to do. Do the last 2 practice problems on section 2. Okay, you may want to grab the 2 worksheets that were laid on the tables. There's a unit circle and a trig chart. I'm going to talk about those here yet before we leave, but you're going to be able to fill in a lot of that chart. Okay? Can I have one of those unit circles, please? Okay. These unit circles are pretty handy to have, okay? I tried to put one on the tables. You're welcome to grab one of those along with the trig chart. You'll see all of the angles that we'll use around this unit circle. You'll also see all the x and y values around that unit circle. Keep in mind, the x values are your cosines, the y values are your sines, okay? So yes, you can pull values right off of this thing, okay? So if you want to go, you know, cosine of 180, okay, well 180 is right over here, cosine is my x value, there's my answer, -1. If you want to do sine of 120, you can go, okay, there's 120, sine is my y value, answer, √3/2. You can pull everything off of here, but I kind of want you to think through the process because you're not going to be able to have this in front of you all the time. Okay? It's just a nice tool to have. I also put some other identities on there. You'll use this sheet of paper pretty much throughout this entire semester to potentially help you. Okay? So it's just a handy little thing to keep close. All right, the other thing I passed to you was a big table of values. I steal a table from somebody. Thank you, I'll get right back to you. Okay, this table is part of your homework basically, okay, or your practice. Don't worry about the first 2 columns on it, it's all about radians, we'll fill that in later, okay? But the rest of it you should be able to fill in with some of the things that we've talked about so far in class. Alright, it gives you all the different angles here. The next column is about the reference angles, which we've talked about. Okay, and then you'll put in all the sine values, the cosine values, the tangent values, and so on. Okay? This gives you pretty much good practice doing what we've talked about today. Okay? So that's kind of what that table's all about. So anyway, do the last two practice problems on the document.